Hello everyone, in this video we'll see the realization of JK flip-flop using D flip-flop. So the first step is to identify the given flip-flop and the required flip-flop. First step in flip-flop conversion is identify the given flip-flop and the required flip-flop. So the given flip-flop is, we know from the question, that is, it is the D flip-flop, and the required flip-flop is JK flip-flop. Now we'll move on to the second step. So the second step is to write the characteristic table of the required flip-flop, and the third step is to write the excitation table of the given flip-flop. So we'll do the next two steps now. So we have to draw the characteristic table of the required flip-flop. So here the required flip-flop is JK flip-flop. So we will write the characteristic table of JK flip-flop. Characteristic table is, we'll be writing Q1 plus 1, that is the next state in terms of the present state and the inputs J and K. So there will be 8 combination for the input. Now we can write Q1 plus 1. So first case J is 0, K is 0. We know that for J is 0, J is equal to 0, K is equal to 0. Q1 plus 1 will be equal to Q1. So it is 0. And next case J is 0 and K is 1. Correspondingly Q1 plus 1 will be equal to 0, or the flip-flop will be reset. Corresponding to 1, 0, the flip-flop will be set. So it will be 1. And corresponding to 1, 1, the output Q1 plus 1 will be equal to Q1 bar. So here Q1 is 0. So Q1 plus 1 will be equal to Q1 bar, which is 1. Now again 0, 0. So Q1 plus 1 will be equal to Q1, which is 1. 0, 1, it is 0. 1, 0, it is 1. And 1, 1, Q1 plus 1 will be equal to Q1 bar. So that will be equal to 0. So that is the characteristic table of the JK flip-flop we have drawn. Now the third step is to draw the excitation table of the given flip-flop. So we will draw the excitation table of given flip-flop is the D flip-flop. So excitation table is based on the present and the next state. We will write the inputs. So based on Q1 and Q1 plus 1, we will write what is D. So 0, 0, 0, 1, 1, 0 and 1, 1. We know that Q1 plus 1 is equal to D for a D flip-flop. So we can write it directly. So this is the excitation table. Now the fourth step of flip-flop conversion, that is, we have to combine the characteristic table and the excitation table to form the conversion table. So now we are going to form the conversion table. So fourth step is to form the conversion table. So that is Q1, J, K, Q1 plus 1 and D. And now we can write D. So for Q1 equal to 0 and Q1 plus 1 is equal to 0, this case D will be equal to 0. And for Q1 equal to 0 and Q1 plus 1 equal to 1, that is these two cases, D will be equal to 1. So we can write 1. Next case is Q1 is 1 and Q1 plus 1 is 0. So Q1 is 1 and Q1 plus 1 is 0. These two cases. So the output is 0. So 0. And next is Q1 is 1 and Q1 plus 1 is 1. D is 1. Q1 is 1 and Q1 plus 1 is 1. D is 1. So we have drawn the conversion table also. Now we'll move on to the fifth step, that is, using KMap, simplify the logic expression for excitation inputs of the given flip-flop. So using KMap, we have to get the simplified logic expression of excitation input of the given flip-flop, which is the D flip-flop. So we have to obtain the expression for D using KMap. So we can draw the KMap for D from this. So there are 3 variables. So there will be 8 cells, Q1, J and K. So based on Q1, J and K, we will write what is D. Q1 is the present state, J and K are the inputs. Based on that, we will write what is D. So this is 0, this is 1. So we can write the we can mark zeros and ones in the KMap. So it is 0, 0, 1, 1, 1, 0, 1, 0. Now we can do the grouping. So this 2 can be grouped and this 2 can be grouped. And this is JK, this is JK bar. This is J bar K and this is J bar K bar. This column, first column is. This is Qn bar and this is Qn. So we can write here in the third and the fourth column J is common and the row is Qn bar. So this is J Qn bar, and here for the first and the fourth column it is K bar is common and the row is Qn. So it is K bar Qn. So we can write the expression for D as J Qn bar or K bar Qn. Now we'll move on to the 6th step. So that is, draw the circuit of the desired flip-flop, that is the JK flip-flop, using the flip-flop conversion logic which we have got now, and the given flip-flop, that is the D flip-flop. So using D flip-flop and this conversion logic, we'll we'll realize the JK flip-flop. So first let us draw the D flip-flop. So D flip-flop is the input is D and a clock pulse. I am giving a positive edge triggered clock here. We can give a negative edge triggered clock also, and the outputs are Q and Q bar. So we can use this flip-flop conversion logic and this D flip-flop to get the JK flip-flop. So the conversion is D is equal to D is J Qn bar or K bar Qn. So we can use 2 AND gates and OR gate to get this expression. So to the first gate I am giving J and Qn bar. Qn bar is the present state. Based on the present state and the inputs J and K and the clock, we will get the next state, that is Qn plus 1. So generally I have written Q bar over here. So I am taking Qn bar from there. So based on Qn bar and the JK inputs and the clock, we will get the next state Qn plus 1 bar. So this is Q bar or Qn bar, and next is K bar Qn. So I can take the K input and invert it and give here, so that this becomes K bar, and I am giving Qn, or in general this is the Q output. So based on the present state and the inputs and clock, we will get the next state Qn plus 1. So generally we have written it as Q. So this is K bar Qn and this is J Qn bar. So we have to OR it. So we can give this outputs to an OR gate. So the output of the OR gate will be equal to J Qn bar or K bar Qn. That is given as input to D. So now our inputs are J and K and the clock pulse, and the outputs are Q and Q bar. So we have realized the JK flip-flop using D flip-flop.